Okay, so hello everybody, let's do this. It says, consider this polynomial, x to the fourth minus 3x squared minus 4. It says, what are the solutions? So there is one factoring technique that some of you have learned and some of you have not, and it's called a UGOT technique. Well, that's what I nicknamed it. So let's see how to use this technique to factor something to the fourth, because you're not used to seeing something like this. You're used to seeing something like this. If I said, for example, how do you factor this, right? Well, this is very easy peasy. You just say, what two numbers when you multiply give you 12? Oh wait, my bad, camera angle was bad. What two numbers when you multiply give you 12, but when you add give you 7? This is easy peasy, you know this. This is just x plus 4, x plus 3, okay? And then what do you say? Or if this equals 0, then you say x plus 4 equals 0, x plus 3 equals 0, x equals negative 4, x equals negative 3. And that's it. But notice how these two are very similar, but you're not allowed to say this technique because you have an x to the fourth. When are you allowed to say this technique? Only if you have some ax squared. So then how do you use a UGOT technique here? What you do is you say, let u equal x squared, okay? So you're just gonna start it off like that. So if you know u is x squared, what does x to the fourth equal to with respect to u? And this should be u squared. Because here, if I were to have u is equal to x squared, and if I just squared both sides, then this becomes u squared. And then what does this becomes? X squared squared becomes x to the fourth, because you have x squared and you're having two of them, and that equals x to the fourth. And why does this help us? Because if you say, for example, and we'll just repeat this again, you say u is equal to x squared, and then you say u squared is equal to x to the fourth. Well then, anywhere I see x to the fourth, what can I represent this x to the fourth as? U squared. And anywhere I see x squared, I could put u. So this becomes plus 7u plus 12. And you're saying, oh, what was the point of that? Well, now notice, what is my exponent over here? What is this exponent over here? It's 2. So now you can say, what two numbers when you multiply give you 12, but when you add give you 7? You could say that technique because you have the exponents are okay right now. And what are those numbers? You already know it. It's u plus 4, u plus 3. But notice, what does u equal? U is equal to x squared. So you say x squared plus 4, then it's x squared plus 3. And then that's how it factors. So let's see, why does that work? Like if I say x squared plus 4 times x squared plus 3, what happens if you were to FOIL this? Hopefully, what should we get? We should get this. Well, let's try and FOIL it, right? X squared times x squared is x to the fourth. X squared times 3 is 3x squared plus 4x squared plus 12, and voila, there it is. Okay, and there it is. So that's a really cool technique. All right. But then, you see, the idea is, if you know that this is equal to this, right? Can you continue factoring? That's the question. So once you get to this point, how do you factor this, and how do you factor this based on the previous lesson that we just had? How does this factor? Remember, it'll be x plus 2i, x minus 2i. How does this factor? X plus radical 3i, x minus radical 3i. Okay? And that's how you create a linear pattern of this. All right, so what I want you to do is try and do these two on your own. Try and factor these two using a UGOT technique. All right? So let's see. And let's say you tried it on your own. How does this work? Well, all right, you say u is equal to x squared, so u squared is equal to x to the fourth. Then I just substitute u squared is x to the fourth plus 2u minus 8. But then how does this factor? It's just u minus u plus 4, u minus 2. Because you say what two numbers when you multiply give you negative 8, but when you add give you positive 2, it's these two. But then what does u equal? U is equal to x squared, so you say x squared plus 4 and x squared minus 2. But then can you continue factoring? This is x plus 2i, x minus 2i. And notice here, this is x minus radical 2, x plus radical 2. Okay? Here, you're not going to use an I because it doesn't have a plus sign. Right? Okay, what about here? Same idea. U equals x squared. U squared equals x to the fourth. So then this becomes u squared plus u minus 20. But then how does this factor? What two numbers when you multiply give you negative 20, but when you add give you positive 1? It's u plus 5, u minus 4. But then this becomes x squared plus 5, x squared minus 4. So now we have x plus square root 5i, x minus square root 5i. And this is x plus 2, x minus 2. Okay? Because this factors like this, and this factors like that. Okie dokie. How do we actually continue with this lesson? Let's see. Try this one on your own. It's saying, what are the solutions, right? Okay. So we're going to use a u-got technique. So here you say u equals x squared, u squared equals x to the fourth. Then you say this is u squared minus 3u minus 4 equals 0. But then how does this factor? It's u minus 4, u plus 1 equals 0. Then this u is same as x squared, so you have x squared minus 4, x squared plus 1. Now this becomes, how does this factor? X plus 2, x minus 2, x plus I, x minus I equals 0. Okay, and then you say what? X plus 2 equals 0. X minus 2 equals 0. X plus I equals 0. X minus I equals 0. So in here, x is equal to negative 2. X is equal to 2. X is equal to negative I. X is equal to positive I. And here are the four solutions. Okay? Now here, let's look at this part. It says, how many x-intercepts does the graph of the equation x to the fourth minus 3x squared minus 4 have? So if you were to actually graph this, based on the solutions, where do the x-intercepts have to be? Okay? And this is from a little review from last time, just a little hint reminder. Only the real solutions will intersect the x-axis. The complex solutions will not. So here, notice that what were the real solutions we have? They're the 2 and the negative 2. So you know that this graph has to intersect at these 2 points. Whatever the graph looks like, right? I don't know what this graph will look like, but I know it has to hit those 2 points. It won't hit these 2 points at all over here. Okay? So why don't you write a little justification for that? And here it's saying, are the solutions to the polynomial p of x equals 0 the same as the x-intercepts of the graph? No. Why? Because only the real solutions will intersect the x-axis, not the complex. Okay? All right. That's it for this part of the lesson. I hope you enjoyed it.